All right, so today we're talking about functions, and we've thrown this word around all week, but today we're really going to dive into what it means for something to be a function and how we know if it's a function, okay? So all relationships between any numbers we call a relation, okay? So any kind of numbers that are related to each other, we have like points, you could have a graph, right? Those are all examples of relations. They don't necessarily have to be linear, and they don't necessarily have to be a function, okay? Domain is talking about all my x values, or if you want to think about it in terms of input, okay, domain is my input and range is my output or my y values, okay? And the reason I can remember this is if you remember, D comes before R in the alphabet and X comes before Y in the alphabet, okay? So D and X are my first letters, R and Y are my second letters, all right? This next part that I have highlighted is the key for today. So underline it, circle it, highlight it, whatever you need to do. This is the definition of a function, okay? Function is a special kind of relation in which each value in the domain is paired with exactly one value in the range, okay? So that's the key, is that word exactly. Meaning there's only one y value for every x, okay? So basically our x's don't repeat, okay? We're only going to have one x value for every single y for this to be a function. Often this helps kids remember it. We always say don't repeat your x's, right? If you break up with someone, there's a reason, okay? Don't get back with them, okay? Don't repeat your x's. We don't want our x values to repeat, okay? We want our x's to be loyal. Each x should be with one y, okay? We don't care about the y's. We care about our x. So let's look down here. It says identify if it's a function using a mapping diagram. Okay, so mapping diagrams are really important. I'm going to ask you what to do that on the test. Okay, you're going to need to know what I mean. Our mapping diagrams are made up of our domain and our range. Okay, and remember, domain is all my x values. So it's all the first numbers in each of my points. Okay, and I'm going to list them in order, least to greatest, and I'm not going to repeat anything if it shows up more than once. So for example, in order, I've got -2, 0, 4, and 5. Okay, in the range, here's all my numbers that I'm going to use. I'm going to write them in order, least to greatest. So I've got 0.5 first. I've got 2.5, and notice I only write it once. It counts for both of them. And then 6.5. Now my mapping, what I'm going to do with mapping is I'm going to show what number is in a relationship with what. So who is -2 in a relation with? 0.5. So I'm going to show that by drawing a line. Okay, and then our next one, 0, 2.5, 4, 6.5, and then 5, 2.5. Okay, so we look at this. I've got my domain, my range, I've got my mapping. And now I'm going to see if it's a function. Well, I look at my x values. Because I only have one arrow coming from each x value, this is a function. Okay, again, I do not care about this 2.5. Yes, it has two arrows going to it, but that's in my range. I only care about my domain or my x's. All right, look at our next one. Okay, so here's my domain. Here's my range. Remember, my domain is my first number in each point. So when I write this, I'm going to go in order. So I have 4, 5, and 6, because 6 counts for both of those. Then I have my range, which is all my y values. Those in order go 3, 4, 5, 8. Now for my mapping, so let's see, 4 is with 3. 5 is with 8. 6 is with 5. And 6 is with 4. So here we have a problem because my 6 right here is being disloyal. He's cheating. Okay, he's cheating on my two numbers right here. I got two arrows coming from him. So because he's cheating, this is not a function. Okay? All right, go ahead and try our next one. All right, so hopefully you got that it was a function. Here's my mapping diagram. The only thing that should fix is these two numbers actually need to switch. My -2 should be first, okay? All right, the next way that we tell if something is function is through its vertical line test, it's called. Okay, and it basically uses the same rule. It's just we're looking at a graph this time. Okay, so if we look at a graph, for example, let's plot these points. Let's say this is just a -4. I'm not sure why that slash got in there. So we've got -4, 4, up 2, we're about there. We got 3, 1, 0, -2, 4, -1, and 1, 2. Okay, so what I'm going to do here, let's see if I can do this. Okay, maybe. Set angle, let's say 90. Yeah, perfect. Okay, so we take a vertical line, okay? So you can use a pencil, you can use a ruler, you can use your finger, I don't care. Here's my vertical line, right? Or imagining I'm on this side of my ruler, okay? What I'm going to do is I'm going to move my vertical line across, okay, my graph. The goal is for my vertical line to hit no more than one spot every time that my graph hits. So for example, here, I'm hitting my graph right here, but nowhere else. Here, I'm hitting my graph here, but nowhere else. Hitting it here, but nowhere else. Here, but nowhere else. Here, but nowhere else. So this passes my vertical line test, so this is a function. Okay, look at our next one. Move my vertical line across the whole graph. Everywhere I go, it's only hitting my vertical line in one spot, so this is a function. Whoa, a lot of things going wrong there. Function. Okay? Just for an example of not a function, let's imagine I had a circle graph. Okay, so if I have a circle graph and I move this along, right here I'm hitting in 2 spots. Okay, no good. So this would be not a function. Okay? All right. Now let's talk about what we call function notation. Okay? So function notation looks like this. It's just a fancy way of saying y. Okay? So our output. Now we read this as f of x. Okay? And f of x is basically a name and a set of directions. So your f of x is telling you I'm talking about this equation, and whatever is in my parentheses is going to go in for x. So for example, if I have f of smiley face, I know I'm using this equation, but I'm going to plug in a smiley face for my x. Okay? Whatever is in here is what we plug in for x. Okay, so let's practice that. So down here it says the function w of x is 250 times x represents the number of words wx you can read in x minutes. How many words can you read in 8 minutes? So I'm giving you 8 minutes. I'm giving you x. So in function notation, we would replace my x with an 8. Okay, so this is saying w of 8, and I would plug in my 8 for x. Okay? Then we would solve this, and we would get 2,000, don't forget your units, words. Okay, because that's what our w of x is talking about. Go ahead and try our next one. Okay, so we had m of 15, because I was giving you 15. Okay, and we plugged it in for x, and we solved. Okay. All right, last page. One thing I might ask you here is to find the range. So I'm going to give you a domain, okay? So I'm giving you a domain. I'm giving you a list of x values, okay? Your job is to figure out what my outputs are or what my range is, okay? So all I would do is I would take my numbers and I'm going to plug them in for x, one at a time. Okay. I would keep going all the way. We're doing every single line. This is what we did at the very beginning of this chapter. We just didn't use function notation. Okay. And then if you were to solve this, we would get, we would get 2.5, 1, negative 0.5, and negative 2. And then good mathematicians, we should write out our range like we were given our domain. So negative 2, negative 0.5, 1, 2.5. Okay, that's what we're looking for. All right, go ahead, try our next one. You might need to make your own chart. All right, so this is what we should get when we plug all that in. I wrote my range as a set. Okay, I plugged everything in between. All you really need to show me is this, and that, okay? At some point, you'll be able to just omit this. You'll just know what you're doing. All right, last question here. It says you have 3 quarts of paint to paint the trim in your house. A quart of paint covers 100 feet squared. The function A of Q equals 100 Q represents the area A of Q in square feet that Q quarts of paint covered. What domain and range are reasonable for the function, okay? So we're thinking about domain. We're thinking about our X values, okay? Our domain is talking about Q in this problem, okay? If you notice in my chart, I just have 0, 1, 2, 3 listed, okay? However, is it possible to use up a decimal amount of paint? Absolutely. So we need a domain that's going to account for that, okay? So my domain is talking about Q. The lowest amount of paint that I could use is 0, right? I could just not paint at all. So Q needs to be at least bigger than 0, okay? But I have 3 quarts of paint to use, so I can't use any more than that. The most I could use is 3. Okay, that's how we write our domain because it accounts for my decimals. Range responds accordingly, right? So here's my range. My range is thinking about my area that I've been able to paint. If I use 0 quarts of paint, I'm going to paint 0 feet squared of my house, right? And then if I use 3 quarts of paint, I'm going to paint 300 feet squared, okay? All right, what if you have 7 quarts of paint? What would change? Well, my domain would still start at 0, right? I can still use 0 of it, but the most I could use now is 7, okay? And then my range, again, I could paint 0%, right? I just do no work that day. But my area could get up to 700, okay? And that comes from our equation. A of Q is 100 Q, right? So I just plug in 100 times 7. And the last but not least, why does it make sense to have domain and range values less than 0? Well, it can't be a negative. I can't use negative paint, right? Negative paint? If you went and asked for that at the store, they would look at you like you had 4 heads, okay? Doesn't make any sense to have negative amounts of paint.